All right. My name is Brandon Kane. I'm the Vice President of R&D at Angoss Software. I have a few slides, and most of what I'm going to show you today is a live demo of our software and how we've embedded the Lexalytics engine into what we do. It's a little bit different than a lot of the stuff we've been looking at so far this week. So I'm going to talk a little bit about kind of how we see our position within the market, within the sort of that business intelligence and analytics space. Angoss has been around for a long time. We have primarily operated in the predictive analytics and data mining space, looking largely at structured data. So we have a long history of working with companies on credit risk and marketing and a few other kinds of areas, which I'll talk a bit more about. We've really focused on improving performance through ease of use. So we offer a set of software tools that really make it easy to get into the predictive analytics space. A lot of our competitors offer very powerful tools that are very hard to use. You're learning coding languages, and you're really operating at a very kind of low level within that software. And as a few people have talked about over the last day or two, is there's a couple of issues in the industry around skill sets, right? So there's a shortage of talent. So one of the ways we can address that shortage is by making tools easier to use to make them available to a broader user base. So instead of worrying about adding talent to the pool, we can make the pool bigger by reducing the need for the sort of low-level coding talent. So our philosophy has always been making things accessible through ease of use, make them quick to get information in and out of our tool and deployed into a real kind of usable sense from a business point of view. So the predictive analytics and the statistical analysis that we're doing is interesting, but it's useless unless you can actually deploy it in a way that increases revenue or reduces costs or tells you something about your customers. So we have a huge client base. It's all logos that you'll recognize, and there's many more. We could fill up slides for the whole presentation with logos if we wanted to. What we find is once companies get our software, they stick with it. We have a 97% plus renewal rate on an annual basis for customers sticking with our software. And what we find is that they've, in some cases, some of the banks and other ones have started off using it in a credit risk capability, looking at sort of predicting the likelihood that people are going to default on their lines of credit or their mortgage. But they've slowly started moving it out of that and into really the sales and marketing side of things is really where we've spent most of our efforts over the last couple of years in terms of new features and functionality in our products, is to bring that kind of same predictive analytics capabilities to something that's outside of that core credit side of things. And as you can see from some of the clients that are on here, there's a lot of success in that field. Some of the use cases and business problems that we look at, there's a whole bunch of them, and I won't go through all of these, but the key thing for us is companies have been doing this kind of analysis and looking at these kinds of problem areas with structured data for a while. And more over the last few years, we've been seeing companies coming in and looking for ways to augment that structured data. They've got tons of unstructured data as well, from product reviews, from customer service notes, from customer service emails that are coming in. There's all kinds of sources of text that they want to be able to use in all of these kinds of things, and whether it's on the credit scorecarding side of things to insurance fraud, looking at claim notes and things like that from insurance claim, or any kind of customer segmentation and analysis there. So there's lots of things that we do on the structured side and been doing for a long time very successfully. And what we really wanted to get into was how do we bring the unstructured side into all of this? And so that was where we started our partnership with Lexalytics to really embed their engine into our predictive analytics workbench. And I'll talk more about that in a bit. We offer software as well as cloud solutions for a lot of companies that want to get the benefit of the predictive analytics side of things but don't have the expertise or desire to work with their own IT organizations in-house. We offer a series of solutions for this kind of thing as well. Most of what I'm going to be showing today is on the left-hand side here on the software component of it. And we have a broad range of tools. I'm just going to be scratching the surface of some of the key points today. But there is a sort of a large base of analytical tools available to users within this kind of a package. We've been recognized by all of the analysts over the years, and this is kind of an evolution of how things have gone here for us. On the left, we start with Gartner's last Magic Quadrant for data mining, which they haven't updated since 2008, which evaluated a version 6 of our product. We were ranked as a challenger there. Forrester's was the next one who did a wave in 2010 and evaluated our version 7. We were a strong performer there. And Forrester's just in the process now of doing an update to this wave. And then most recently, Hurwitz found us a victor in the customer view segment of their predictive analytics survey as well. And that was on version 7.5, which came out last year. So now we've launched version 8. It came out in May, which includes all of the text analytics capabilities with the Lexalytics engine. And we're looking to see how that is perceived by the market, and we expect ourselves to continue moving up sort of the rankings of these analysts they're coming in and looking at these kinds of things and sort of consistently recognizing our progress and functionality over the years. So then we talk about what is predictive analytics. Essentially, there's a whole huge space within business intelligence. It's massive, and there's a whole bunch of different components to it. And a lot of the stuff we've seen today and yesterday is really focusing on one of sort of the first 3 bands here. Almost nobody was talking about sort of pure reporting and business intelligence from a reporting platform tools this time, but we've seen a lot of stuff on the analysis, on monitoring, seeing what's happening in these markets, and what your customers are doing. Where Angoss focuses is on the outside, the prediction. What might happen next? Where are we going from here? And so this is a key component of everything that's part of our philosophy is looking at that prediction side of things. So what's happening right now, what happened yesterday is fascinating. You need to do it, but you also want to be able to predict what's going to happen next. Especially once you have all of the monitoring analysis in place, it gives you a framework to see how your predictions are behaving. So if you're predicting the likelihood that a customer is going to respond to an offer, if you don't have a way to track and see whether they actually do respond, then you can't measure the impact of those predictive models and decisions. So all of these stages are necessary, but once you want to get to sort of that top tier of what is going to happen and how do we predict the future. So in terms of the predictive analytics, here's just some examples of the kinds of things. It's all about probability. Right, so what is the likelihood that something is going to happen? Some event is going to occur in the next 30 days or in the next month, or that a particular insurance claim is fraudulent. All of those kinds of things are what we deal with on the predictive side of things. And so we can do all of this with structured data that's available, but what I want to sort of show today is that you can augment all of that structured data with the unstructured components of things that are coming out of the Lexalytics tool. So essentially, what we wanted to do with the text analytics is really do what we've done with a lot of other statistical algorithms and other kinds of predictive analytics, is take the core engine, which Lexalytics provides, and embed it in our software and make it easy to use and accessible to end users. So what this really gives you is the ability to merge the two together. And so I'll show some scenarios where this happens, but basically the theory is, and what we want to try and get our customers looking at is, adding additional variables to your models should increase their predictive power. And there's all kinds of stuff you can extract from your text to be able to increase that predictive power of your models. And so what we started with in our current release of Studio 8 is sort of the core components of the Lexalytics engine. So entity and theme extraction and sentiment analysis, both at the document level as well as at the entity and theme level, and document summarization was something else that we included. All of the concept topics and facets and collections and other things are very fascinating. We want to include those in some of our next releases, but we wanted to sort of get a good start on things with the initial features of Studio 8 with sort of the core components of Lexalytics. So what I'm going to do is talk about and go through a scenario here, and I just wanted to kind of set up what kinds of things we're talking about. So this is review data from an online retailer. These are DVD reviews, so I took a subset of a huge set of reviews that were out there to really look at for this. So it's something that's manageable for a demo, but obviously you can get into much bigger than this. We get a bit of structured data about the member who made the review, the product they were reviewing, and some of the structured data from the review itself. So you get a 5-star rating, or you get the sort of metrics around who found it helpful and things like that. So that structured data is there, and it's still available for analysis. But obviously the content of the review, as we've seen, has huge value to the organization, and we want to see if we can use that to augment a purchaser model. So what we're looking at is the likelihood that someone's going to make a purchase after they've left a review. So if I buy a product, I review it, I post my review, good or bad, I may come back and make further purchases later with the same website. So can we predict whether or not that's going to happen using the stuff that the person is putting in their review? So that's really what we're trying to show and what we want to see if we can do at this point. So I'm going to switch over to the demo now. So this is Knowledge Studio. What I'm looking at here is essentially one of our simple data set charts. So this is just looking at my overall data set showing the percentage of people who made purchases. So I'm looking at historical data where I know their purchase behavior. So I can see about 20% of our population had made purchases, and this is again tied to the sort of the 3,000 reviews that I've had that I've put in here for analysis. I have all kinds of tools at my disposal to sort of get an idea of other things that are in the data. So I can look at the distribution of the list price of things that are being reviewed. I can look at the number of people who found something helpful, all of that kind of stuff. So there's lots of ways to explore the data, and this is a big part of what Angoss does is really to be able to explore this data. But again, this is all looking at structured data. So we want to be able to do the same kinds of things with some of the unstructured components. So one of the things that's a helpful way to visualize this is something we call the segment viewer. And what this does is really takes a breakdown of the different fields in your data set by the purchase behavior. So in this case, what I'm seeing here on the left-hand column is my entire data set. What is the distribution of list price for the data set as a whole? The middle column is what's the distribution for people who did not make a purchase afterwards. And on the right is for people who did purchase. And so what I see here is, certain things will be very different between the two groups. Some things will be fairly similar. So I can see the list price here doesn't have a huge impact being different between the two. The number of people who left feedback or found it helpful weren't particularly different between the two groups. And what that means is they're probably not very good predictors of whether or not someone's going to make a purchase. But if I go down a little bit, I can see the rating that they left is very different between the two groups. So people who had left a 5-star rating were much more likely to make a purchase down the road, which makes sense. If I had a positive experience, I had a great product that I got, likely I'm going to come back and buy something else. So some of it is confirming things that just sort of intuitively make sense, but it gives you an interesting way to quantify it and visualize it. Some of the other fields that are in here, we can see the word count, so how long the review was. Wasn't very much different from the overall population for the non-purchasers, but the purchasers tended to have, shorter, quicker reviews. Their rank in terms of things was in there. The state they lived in looks like it might be reasonably predictive, so where people are located. And so we'll explore some of the rest of this data as we go through the rest of the demo. So what I started off doing was first building a predictive model using only structured fields. So forget about the text. Let's just use the stuff that we had before. And so what this is a decision tree. And essentially what you see at the top here is a node that represents my entire population. And it gives me some statistics about the population, so my 20% of the population that made purchases. And it actually colors the node based on that percentage. So I can quickly see in the tree very visually where my purchasers are located. So what I'm really trying to do with the decision tree is find ways to segment my population into people who had a high propensity to purchase and people who had a low propensity to purchase. And so I'm looking for ones that are significantly different from the overall population of 20%. And I have a little map on the bottom here so I can see very quickly, where the green is where my purchasers are. So I don't need to, go and read all the little numbers. I can just, click and jump to the right place which has the information that I'm looking at. And so what I'll just zoom out a little bit here so you can see the whole thing. So basically this is a small tree. The top field here that is the most relevant driver of purchase behavior is the rating. So as we expected, the people who had a very high rating have a very high propensity to purchase, which is kind of intuitively true. But I can see here there was 24% of the 5-star ratings made purchases, where 12% of the 1 to 3-star ratings made purchases. So I'm getting a decent separation using that rating field on the who purchased and who didn't side of things. And then the rest of the tree uses some of the other structured fields, the state, the number of people who found something helpful, the word count from it, the list price, all had some predictive power in separating these things out. And the software has automatically put together this tree and figured out how to group the different things together. So you can see in certain cases for the high propensity to purchase, people who left high star reviews, the state segmentation is actually different than it was for the 4 and 1 and 3-star reviews. And so what we see is it's, segmenting different subsets of the population differently. So it's using an algorithm to determine what these things are. And I'll explain more of that as I get into the text component of it. So from here, what I want to do is now I want to actually get some text data into here. And so I've already done the analysis, but I'll show you what the wizard looks like. And our whole philosophy with all of our predictive models, and there's a long list, which we can go through afterwards if you're curious, and some of the other ones. But everything is visual. There's wizards for everything. You don't have to write any code. The defaults are all very intuitive and generally accurate. So what we're seeing in some of these cases is, if I want to build an analysis, I don't need to be a statistician. the default settings for these things are usually good enough to give me a reasonably predictive model. There's lots of advanced options for those who do want to get in and tweak it, but there's a lot of easy ability with a few clicks to do very powerful things. So for example, creating a text analysis, I need to actually just pick the data set I have, which is my DVD review table, pick the field that has the text in it. I have some other fields here that I can sort of pass through the analysis if I want to join them in or include them later. And then I just need to pick some names for some of the output tables that are going to get created as part of this. So we're going to create tables for entities and themes and some information about the document. And that will give us what we need. So I don't have to write any code. I don't have to configure anything. I pressed a couple of buttons, and I'm going to get a text analysis. So I've already run it because it takes a couple minutes to run, or a minute and 30 seconds to analyze all these reviews. So it's performant. But what I get is a summary. So I had my 3,000 reviews, and it tells me what it found. So I got 11,576 document entities, which boiled down to 6,000 unique entities and 21,000 unique themes. I'm not going to go through and read all of those any more than I was going to go and read the 3,000 reviews that I was looking at to try and predict behavior. So what I really want to do is have a way to filter it. So these are all DVD reviews, so the people tend to be the actors or characters or people involved in these movies, so you'll recognize lots of them. So this is just a way to visualize some of this data and really explore it and filter it in an interesting way. So I can look here, and what I'm looking at right now is who is the most frequently mentioned. That's something that comes up commonly in the predictive analytics world is what is the most frequent thing that's happening? How often are people talking about a particular actor or character in the context of these reviews? And we'll see down the line whether or not that's predictive. I can do other things like looking at places. I can also filter on the number of documents. So if I say, show me places that were mentioned in at least 10 documents, and tell me which one was the the highest sentiment on average. Right? So we can see very quickly what people are talking about and what they think of it. So Paris, France was the most frequently discussed, but it wasn't necessarily the top of the sentiment analysis. So again, it's a way to kind of explore this data and get an idea of what's in here. There were similar side of things for themes. Right? So we're looking at the themes in terms of what was discussed. Was it positive? Was it negative? And again, this is just kind of exploring the data a little bit. So this is part of that first part of the analytic process, which is data exploration and analysis, just to see what we've got. So we can see here, special effects, good movie, Pulp Fiction. It was one of the most reviewed movies on the site, so you'll see some of that stuff show up fairly frequently. The main character of the film was another one. And again, I can do all the same kinds of things here to explore the different things that are part of the data to see what's really in here. From here, what I want to think about is how do I get this into a predictive model? So now it's structured, right? It's in a table. I've got all of these themes and numbers and stuff that predictive modelers love is numbers, right? So I've got numbers, but they're in a structure that is not particularly conducive to data analysis. So I've got one row for each entity or one row for each theme. I need to be able to pivot and augment that into something that I can feed into a logistic regression or decision tree or something else that will allow me to make a better prediction. So what we have is all these check marks over here is basically a way to include certain things into that data set that's going to get created. And we've got, again, another nice, easy-to-use wizard that will do the same kinds of things. So let's say I want to find out or use whether or not people are talking about special effects and the sentiment, a number of mentions and things about that particular theme in my further analysis downstream. I can select these for inclusion. Another thing which we do on the output is, we can include, obviously, a lot of information about the document that we're getting from Lexalytics. And from here, I can also choose to include things like the top-ranked themes and entities. So within a document, I might have two documents that talk about totally different things. But if the theme that was most prevalent or that was most relevant in that document had a high or low sentiment, that might be predictive. Same thing with the entities. It might not be relevant that I talked about a particular actor or director in the review, but the fact that I talked about the fact that the thing that I talked about the most is very positive or negative could be relevant. And so that's another way that we can do this here. And then I can review, obviously, all the things that are going to get created, and it's going to automatically create me a big view that has all of this stuff merged into it with a column for each of these different attributes and a row for each document that I fed into the table initially. And then from the other components that we have, we can actually join this new analytic data set back in with a whole bunch of other things we know. So in this case, I've generated another data set that has all of these fields together. So what this is essentially my whole data set that I know everything about my customers. So I've got the member who made the review and all the things I know about the member. I've got the product they reviewed and all the things I know about the product from the structured side of things. I've got the review itself and the structured and now unstructured things I know about the reviews. And so instead of having 10 fields to be able to build my decision tree on, I've got 70 now. And so one of the things that our tool is very good at is helping you figure out from this huge list now you've got, what are the things in here that are actually predictive? So that's where we get into sort of our next component is, how do we tell, now that I've got 70 things to look at, what's predictive? So I've got another decision tree here, which I've built on this new data set that has all of my attributes for both the structured and unstructured data. So it's got everything that the other decision tree had, plus a whole bunch of new stuff. And so I'm going to start from scratch on this one and sort of walk through the process of building one of these. The first and most important thing is to be able to do what we call find split. And what this does is it looks through all the different fields that are in your data set, looks at how well they segment and predict your dependent variable, in this case the likelihood that someone's going to purchase later, and segments your population based on groupings of those categories. So essentially what this has done behind the scenes is created this split report, which is a whole bunch of numbers that don't really matter, except for it allows you to rank all the variables. So it's a way of looking at what things best predict the purchase behavior. And so we see for the whole data set, the document sentiment, the overall sentiment of the tone of the document is what is the best predictor. So this is what people are actually saying in the review. So the actual rating that they gave, whether it was a 3, 4, 5-star rating, has been pushed way down the list. So we see, the rating is still on here. It's still predictive, but it's not nearly as good as the actual sentiment that was coming out of the engine. And so there's a few other things that are on here that will show up as interesting predictors. But if I go back to the tree now, I can look at this data and I can continue to build out my tree in this way. So if I go here and find a split on the next node, I see that the next one is the top ranked entity. So what was the thing they were talking about the most? And that is actually a good separator there. If I look at one of the other ends of the spectrum, I see for this group here, the state is actually a better predictor. So it's redoing all that calculation to re-rank everything based on its information value at every node in the tree. So you're getting different splits and different groupings of variables anywhere you go in the tree to try and predict that purchase behavior better. The other thing you'll notice here is the segmentation I got is much better on this one. So if I look at the people who had a 5-star review, remember we saw that it brought our purchase percentage up to 24%. Here I'm getting 43% by using the sentiment as opposed to the star rating to do that. And so one of the things that we can also do is force our tree to segment our population in a way that makes sense to us. So in some cases we may have specific business rules around things that we want to do. So let's say I want to actually break things up by region first. So I have a way I can easily come in here and edit these regions and group things. But I can see the purchase behavior isn't greatly different across all the different regions. It's pretty consistent. But what I find is I might actually get different segmentation in different regions. So for example, on the west side of things, the document sentiment was the best predictor. If I look at central, I see that the top themes sentiment is actually a better predictor. So whatever the thing was that they were talking about the most and what they felt about that particular theme was a better predictor than the document sentiment overall. So this is another way that we can look at and explore the data. You can build this tree interactively, and a lot of analysts like to do that because they like to be able to see what's happening at every different level. But for those of us who like machines to do everything for us, we can just press a couple of buttons and it will actually do that fine split operation at every node in the tree and grow you out a nice big tree that will split everything based on its most predictive variable at every level down to some defined threshold. So once a node gets to a certain size or you get to a certain number of levels in the tree, it'll stop there and use that model to as your decision tree. And so there's lots of ways to deploy all of this as well. We can generate code from these models to deploy into other systems. We can do all kinds of things to score this data internally as well. But one of the things that we want to try and do is be able to compare these two models. So yeah, it looked like I was getting better segmentation on my population from this model, but how do I really quantify that and tell whether the two are different? And so what we have for that is something called our model analyzer. Again, using a couple nice, easy wizards, we can insert a model analyzer, which will allow us to plot how good our model is at predicting the data that we've got. So first I'll put the, my no-text version on here that just used the structured data that we had. And I'll just evaluate the model. You can also evaluate this against a data set that wasn't used to train the model, so you can see how it behaves against other data. But basically what it's doing in this case is looking at how well does the model predict that purchase behavior. And so what this chart represents, the straight line is essentially how good would just a random sampling be. And so if you think about sort of the sending out an email offer, if you send out 1,000 offers, and you're going to get out of that population, for round numbers, say 100 people respond. If you said, okay, I only want to send out half that number of emails, I'm going to send out 500 emails, and you just did it randomly, you could probably assume that you're going to get 50 respondents to your email. 50% of your population is going to get 50% of your target. And so that's what that the straight line here represents. 50% of my target gets me 50% of my population. Or, sorry, 50% of the population gets 50% of the target. What the model represents is if instead of just picking people randomly out of a hat, you use the model to pick people that were most likely to respond, you'd actually get closer to 70% of your respondents. So sending out 500 emails, you're going to get 70 responses as opposed to the 50 that you would get just on a random sample. And so, this is sort of the measure of how good a predictive model is how much better than just a random sampling is it going to be. And so what we really try and do is always pull that lift up as much as we can. And so what I can do next, is add the my with text model. And so what we'll see here, hopefully, is that the model with text is better than the one without. And we see it is. So here at 50% of my population with the no text model, I'm at 70% of my target population, and at with the with text one, I think I'm at 82 here, or 81.7. So a 10% lift at that 50% mark is very interesting. So one of the things you can do is that just sort of quantifies the fact that this model is better than another model, and so we can use that to do further analysis and get things done from there. One of the things we can do is actually, if it is a sort of a profit-based thing you're doing, like offers, there's some sort of expected revenue coming in from each unit that responds. There's a cost to that, and there's a fixed cost associated with the campaign. So if I plot a few things in here for, say, I'm going to get $4 of revenue per customer, cost me $10,000 to run the campaign, cost me $1 to send out the coupon or whatever it is, and I want to do this for, say, 100,000 people. What it'll do is it'll actually plot out your profit and loss at each percentage of your population. So, yeah, you're going to get different response rates, but where should you draw the line? And so what we see here is for the two different models, we get kind of different peaks on it. And for the no-text model, it's actually negative at every point. But if we go above to the with-text model, which has a better prediction rate, we're actually getting our peak profit here just shy of 40%. So that's where if there's a cost to sending out those offers, that's a way to kind of decide where to draw the line. All right, so if you want to get your entire population of responders, you've got to send them all out. But the model can help you send out a smaller number of offers and get a relatively high response rate. So this is a way that we can sort of guide our strategies based on some of this data that we're pulling in. Some of the other neat things that we have is really around exploring the data and visualizing it in other interesting ways. So one of the things that we have is something called market basket analysis, which is typically used for product associations and finding patterns within different groups. So if you think of going to the grocery store, you put a bunch of stuff in your shopping cart, you get up to the front and we see what are the things that commonly were purchased together. And so you can use that for recommendation engines and next best offer and those kinds of things. But it also works really well with text data because we have groupings of themes and entities that are grouped together by the documents we found them in. It could also be grouped together by the page from a website they came from, or a group of customers from a particular country, or wherever else things you want to group them on. So this is a way just to visualize some of that data. So in this case, I'm looking at a very small section of one of these maps. I'm zoomed in at 460% here to show you kind of what this looks like. But basically, it figures out all of the patterns of how frequently things went together, and they're plotted on the map using a multidimensional scaling algorithm to really put things that are frequently found together close together on the map. So if they repel each other in general, because they're not found together, they will appear far apart. So in this case, I've highlighted a movie that I quite like, Grosse Pointe Blank, which is a movie about a hitman who goes to his school reunion, He's played by John Cusack, and the character's name was Martin Blank. And then a whole bunch of other people around here are characters in that movie or actors who played in that movie or are on the soundtrack or whatever it is. But we see there's a whole bunch of other stuff that has shown up here that is clearly not related to that movie itself, that has been plotted on here in a similar way because it was discussed in the same review or came up in the comparison. Right? So we see some Stephen King and talk about special effects. Ben Affleck's over here probably because he was started in with Minnie Driver in Good Will Hunting. Minnie Driver was also in Grosse Pointe Blank. So we can see some of the connections start to appear here. So again, this isn't a predictive model per se, but it's a way to explore the data in another way that is very visual, and this can be easily copied and pasted into presentations or whatever else you want to do. And if I zoom out to look at the whole thing, like we can see there's different clusters of things that are in here. And depending on sort of the thresholds you set, you'll get more or less information in these maps, which will allow you to drill into different components of your data. Another way that we deal with some of the structured and unstructured data that was coming in here is really something we call a strategy tree. And this is something that's unique to Angoss. It's something that none of our competitors do, at least not in this way, is really to marry the predictive analytics with the business intelligence and business knowledge that you have. So in this case, what I've done is I've created this tree using a few sort of simple segmentations, and I've colored it based on the average sentiment. So essentially what happens is I've got a calculation at each node here that calculates the average sentiment for that group of people. And then it colors the tree based on who had the highest average sentiment. So I can see right away that these dark green nodes have higher sentiment than the white ones. So it's again, a simple way to visualize it. And if I zoom in here on the root node, basically the calculations that I've added, I've got the average number of people who, or percentage of people that found it helpful, the average sentiment of that group, the top theme that was found in the group, and I've also got the sentiment associated with that top theme. Right? So I can then segment my population based on a whole bunch of different things to really explore those different metrics. So in this case, the first thing I did was split it on the region. Say, like, tell me what the different sentiment is and the different things that are happening in the different regions. We can see that on average, the central folks and the west folks were a higher average sentiment than either the east or the ones that didn't have a region identified. And so let's say we wanted to dig into the central side of things a little more. We can see what the difference is between things that were priced high and low. Right? So for reviews that were for relatively inexpensive items, we see a lower average sentiment than we see for things that were more expensive. And we might see different things in different groups. So we actually look at the west side of things. They were more positive on the cheaper items, and the more expensive ones tended to be lower. And so there's all kinds of things you can layer into here. If you have metrics around profitability or customer loyalty and things like that, you can merge all of that into your decision trees, your strategy trees, to really tie in the predictive side of things with these KPIs and business intelligence. And so we can do all of the same operations in here to find and force splits within a strategy tree to refine the data based on whatever we want. And within the strategy tree, another thing that's interesting is you can actually segment the data on different dependent variables at different levels in the tree. So what I might say is, in one group, I might want to find the best predictor of the likelihood to purchase. But in another one, I might want to say, tell me what the best predictor is of the person's age in this category, right? And segment it that way. So there's lots of different options for how you can interact with these strategy trees. Once you've done that, the other thing that you can do within a strategy tree is assign treatments. So let's say here's my high sentiment group. I'm going to send them a special offer. Right? So I can tag these guys as offer one. And I might want to make that for all of the groups that have high sentiment. And I might want to have another offer for other groups that maybe were interesting, or target markets that that I want to look at but not necessarily make the same offer to. And we can do all the same code generation, deployment, scoring options with these strategies and treatments that are assigned in here with these as well. As I said, there's lots of other options. I've shown some of the more simplistic models here, decision trees, which are kind of a key component of our software and something that we're well known for. But there's lots of other things in here. We've got all kinds of different predictive models for neural networks, linear and logistic regression. Scorecards are mainly used on the credit risk side of things. We're seeing that more and more in other areas as well now. Market basket analysis is a big one. And clustering is another that is something that we see a lot, especially when you're dealing with large volumes of data like this, where you're looking for patterns without necessarily having something to predict. So a cluster analysis would help you, say, find outliers in your data. So what you might find with the cluster analysis is looking at reviews that are similar. So you might say, find me 8 clusters and see how they're grouped together, and what are the different characteristics between these different reviews or comments or whatever it is that you're looking to predict. And you can get a view similar to that segment viewer we looked at, where you're looking at these different clusters. And it's a way to find outliers. So find the reviews that aren't like anything else on a multidimensional sense. So you've got things that are, you can look at a single variable and tell me what the sort of distribution of it is, but how do you do that when you've got 16 different variables and you don't know how they interact? The cluster analysis can help with a lot of that. And there's lots of stuff for getting data sets in and out of our tool. We have lots of data preparation options now as well for joining data sets, aggregating information, removing duplicates, and lots of other stuff within the tool that has a lot of power to really help you learn about your data, help you predict behavior in the future, and really have a positive impact on something within your business that is causing you pain. So we do that all in a very easy to use fashion. It's all wizard driven, it's all visual, it's all graphical. We don't just give you a page full of numbers. It's all about how you interact with the tool and making it easy to use and easily accessible for a wide range of people. So that pretty much sums up the quick tour of Knowledge Studio. So if there's any questions, I'll take those now.
Yeah, I'm guessing that a lot of your customers are in production, have these predictive models that are used to working with the structured data. Mm-hmm. And I'm wondering, as you've introduced unstructured features into the models, what have been your pain points to get them to pull this unstructured data into the same pipelines where their structured data is in production?
Some of them already have the pipeline for that, and it really depends on where they're pulling the data from. So what some of them are finding is they have lots of data and they already know that they need to do something with it. So we see that on some of the voice of the customer kind of things, and places where people are looking at like CRM data, for example. If you're looking at analyzing the notes from sales activities and things like that, they have the text and they know how to get it in because they're already pulling other things from those same systems to use in other models. The other side of things is where they don't have the data. So if they're looking at brand sentiment and things where they need to pull in social media and other kinds of data that they don't have in-house already, that's proving more of a challenge. And so that's not something that we provide, but as we've seen over the last couple of days, there's lots of companies that are doing that kind of stuff. So that's an area that we want to hopefully get more of our customers looking at. Anything else?
So you've got, if I follow this correctly, you've got people who have put reviews in on DVDs on the site, and then you have knowledge about whether they purchased the DVD or not, and we're hoping that you can apply the knowledge you got from that review to the likelihood that they'll make another purchase on the site?
That's right. Or you can even use that model to predict for people that don't have a purchase history, right? So if we see that people who make reviews of a certain sentiment or mention certain things in those kinds of reviews tend to make purchases, then we don't need to reanalyze all that data every time. We can put that model into a system where we can see, as they're entering the review, if they mention certain things or we analyze it and see what the sentiment is, that there's a certain propensity that they're going to make a purchase, so we might offer them a special discount right as they make the review, or try and insert some intelligence into that process based on that model. And so what we see in lots of other places where we're looking at the purely at the structured side of things, what people are doing with these models is they'll use our software to build the models, but then they'll essentially generate the code from the model and put it into another system, whether it's a point-of-sale system or CRM system or something else where those events are happening. And so as the event happens, they'll run the data through the model to get that prediction. It doesn't need to come back to us to do the modeling again. We've already got that kind of intelligence built into the model from the historical data that we analyzed the first time. All right, thank you very much.